Okay, so this is an extra credit level, which means that there may be a bonus like this on the quiz, but this is harder than I would expect for a regular part of the quiz. Okay, so first of all, we have both a policeman and a driver, and because we have both of them, there's different information about both of them. I'm going to suggest taking data in a chart. So we have a driver, and then we have the cop. Okay, so the cop maintains a constant speed, a careless driver is going to, they're maintaining a constant speed the whole time, all right? So the driver's velocity is just going to be right at 40 meters per second the whole time. So that means I can use, since they're always at 40, then 40 is also the average, so I can use the really simple formula. So the V for the cop, or for the driver, is 40 meters per second. Okay? All right? The policeman accelerates from rest. So if I do the whole little thing on him, VI, VF, let's see, DAT. Okay? The policeman accelerates from rest at a rate of 4.5 meters per second squared. Rate is one of those words you don't want to ignore. It's telling you that it's a rate of change of velocity, which helps tell you it's acceleration. The unit also tells you it's an acceleration. That's meters per second squared. All right. And yes, this is what we know about the cop. All right. Now, this is tricky, okay, because you have one piece of data here, and I know that over here I'm going to be wanting to use this formula, because whenever I see V average, it tells me I'm going to need to use that. But I still need an extra piece of data to even be able to use that. And then over here, I certainly don't have three pieces of data. So at this point is where it gets real tricky. You have to realize a couple of things. When the cop catches up with the driver, two things will be the same about them. The time, because time for the cop is the same as time for the driver. All right, and also the distance they've traveled. That's what catching up means. Okay, all right. So not D equals T, D equals D. Okay. So while the initial velocity is only true of the cop, and the acceleration is only true of the cop, and the average velocity is only true of the driver, these two variables are the same for both, all right? And I don't have to be too careful because there's only one VI and only one V average and one A, so I don't have to worry too much about mixing them up, okay? The fact that these are true means that these are the formulas we're going to want to, these are the variables we're going to use in our formula. So on the left side, I want a formula that has D, T, and V average in it. I've already picked it. And on the right side, I want a formula with D, T, A, and VI. And that formula is my favorite. D equals VIT plus 1/2 AT squared. And because the initial velocity is 0, I can do a working formula. All right, now I'm going to plug in what I do know. So I know 40 meters per second equals D over T. And I know that D equals 1/2 times 4.5 times T squared. And I'm going to drop units and get these a little simpler. So I get 40 equals D over T. And I get D equals, what's 1/2 times 4.5? 2.25? Yeah. 2.25 T squared. These are my two formulas. And now what we have are two formulas and two unknowns. And we can handle that. Simultaneous equations. So what I'm going to do is I'm going to rearrange this one here. I want to make slightly more room. And so that's going to mean like I'm going to get rid of something. I don't know. Maybe that. All right. I want to rearrange this and get D equals 40T. Man, I wish I could. I guess we don't need to read it anymore. Okay. So now I have these two. So I have D equals 40T and D equals 2.25 T squared. So I can actually set these equal to each other. 40T equals 2.25 T squared. Now, your math teacher might die inside a little bit for doing this because it's not really what you're supposed to do. What you're supposed to do is set all this equal to 0. But you can cheat and not do that because, all right, I'm going to do it the right way and then explain why you can cheat. All right, so what you're supposed to do is say 2.25t squared minus 40t equals 0, and you're supposed to factor this out. T times 2.5t minus 40 equals 0. Then you're supposed to set both of these equal to 0. So t equals 0 and 2.5t minus 40 equals 0. Now, this is why you can kind of cheat. Well, yeah, they were caught up at time equals 0. No, duh. That's when the cop initially passed the careless driver. So yes, it's true. They had the same displacement at that time, but I want to know this other time. And so if you want to be like math bad and cancel this and cancel that and just end up with this formula, because you're really just discounting the 0 that we don't care about in physics, the old engineering approach, you can get away with that. But I'll continue to solve this one. All right, here we go. So let's see. 2.5t equals a positive 40. Divide both sides by 2.5. And you get 40 over 2.5 is 16. And that means that at 16 seconds, the cop is caught up with the driver again. All right? But that's not what they asked. They asked, how long? Oh, no, they did ask 16 seconds. It's done. All right. So we did the extra credit. And the reason it was extra credit is because you had to keep the two things separate. And then you also had to deal with a quadratic and factor it out to find your answer. All right. Done.